Today we're looking at a special type of linear modeling called direct linear variation. So a direct linear relationship exists between two values, x and y, if when x is increasing, then y is also increasing. So they're going in the same direction, or you could also say if x is decreasing, then y is also decreasing. When we're looking at direct linear variation, linear meaning a straight line, the variables are going to satisfy this equation here, y equals to kx. So you can see it looks kind of like a straight line, okay? But we've got a k in there, and k is a constant, okay? With this value k, it's got special names, particularly for this type of problem. It's called a constant of variation, or sometimes called the constant of proportionality. Okay, so proportionality meaning that it's in proportion. So it's sort of like a number that you multiply x by in order to get the y value. When you're looking at this equation, it does look like y equals mx plus c, except the plus c bit isn't there. So when we're looking for the y-intercept, the y-intercept is always going to be 0. So for these particular variables, if one value is 0, then the other one will always be 0. So some of the types of questions we'll see is questions where we might be drawing graphs. Some of them might be just algebraic problems where you need to come up with an equation and then use it to solve problems. So if we're looking at graphing direct variation, here's an example. So the exchange rate between Australian dollars and US dollars is shown in this table below. So I've given you a couple of values. So if I've got 20 Australian dollars, it's equal to 14 US dollars, or 40 Australian dollars is equal to 28 US dollars, and so forth. So the first question is to graph the relationship between these two values. So what we're going to do is we're going to fill in the axis. So we know that the A values need to go up till 60. So if I put 10, 20, 30, 40, 50, and 60, so that's going to fit quite nicely on the graph that I've got here. If I'm looking at the U value, so it's 14, 28, 42, so it looks like it's going up by like 14s, so if I go 14, 28, okay, that's not going to fit, so I might go up 14, 28, 42, so I am going up by 14s at each of those steps, so that's perfectly fine to do. If you want, you could just go 10, 20, 30, 40, 50, that would work too. So if I go one more above that, that'll be 56. And then one above that would be 70. Okay, so I could go up by these values. So then when I go to draw it, at 20, A is 20, U is 14, A is 40, 42, oh, no, 28, and then 60 is 42. So then what you'll see is it's going to come out to be a straight line. So what we also know is if I don't have any Australian dollars, then obviously I don't have any US dollars. If I don't have money, I don't have any in either of those. So we know 0, 0 is also on the line. So what we can do is we can draw a straight line through those points now, and that will be the line that connects the A and the U value to each other. Part B, we need to find the equation of this line. So we've done a fair bit of this. We know for one, we know the constant is equal to 0. Okay, so again, we're looking at y equals mx plus c, and we know definitely the c value is going to be 0. What we then need to work out is the gradient. So what I could do is I can draw out a right-angled triangle here. So when I'm looking at that right-angled triangle, the vertical bit is 14 and the horizontal bit is 20. So I can use that to work out the gradient. The gradient is going to be 14 over 20, or if I put that into the calculator, it's 0.7. So we've got our m value, we've got our c value, so we can substitute it into this equation now. So we know m, we know c. What we also know is we've got different values for y and x. So x is always your horizontal axis. So we've got a going into there, and then the y value is going to be the vertical, which is u. So that means our formula becomes u equals to, the gradient is 0.7 times A. And it was a plus 0, so we can leave off the 0, and that's the rule. For part C, find the amount of US dollars if I've got 35 Australian dollars. So what I can do is I can either use my formula, put the numbers in and work it out, or I could actually read it off the graph. So when I'm looking at the graph, I'm going to look at where 35 is, which is right there. I'm going to bring that line up. Now I'm going to read that number across. I'm going to work out approximately what that is. Now, if I were using the diagram, it's not going to be as accurate as if I was actually using the equation. So I'm just going to use the equation for this question. So we've got A equals to 35. So we know U is equal to 0.7 times 35. And when we go to calculate it, we just put it in the calculator. It's $24.50. Okay, so obviously when you're looking at a diagram, you're not going to be able to get a value as accurate as if you were using an equation. Okay, so that's when we're looking at using a graph in order to, like drawing direct linear relationships into a graph. What we can also look at is just pure problem solving. So rather than having to draw a diagram, sometimes we'll just go about working out what the equation is and then using the equation to solve particular problems. So here's your steps. So the first thing we're always going to do is identify what are the two variables. So usually we go with X and Y, but sometimes with a practical problem, we will use letters that relate to what we're doing with the problem. And then what we're going to do is write out a variation equation. So your variation equation would be in the form y equals to kx, but instead of using x and y, we're going to be using whatever letters they're giving us. Second step is to substitute known values into x and y in order to work out the value of k. So in this equation at the moment, we don't know what k is, but we may be given a particular pair of results, and then we can use that to work out k. Then we're going to rewrite the equation. We're going to substitute k in. Okay, so we'll have y and x and some sort of number, and then that's our equation that we're going to work with. And then so from there, we can substitute whatever the question number is. So the question will usually go, okay, if I know this value, what is the other value? So now we can do a substitution of that in order to work out the missing component. So here's an example. So we've got the stretch in centimeters of a spring varies as the mass. So it's kind of like you have a spring and then you put like a weight at the bottom and then you just let go of it and you look at how far that string stretches. So we know that if a mass is bigger, so if I've got more weight at the bottom, the spring's going to stretch a lot further. Okay, so you can see that as S increases, M is also increasing. Okay, if M is smaller, then the stretch will also be smaller. So we've got S and M are the two variables we're going to be using. A load of 24 kilograms, so I'm going to use a different color here. 24 kilograms causes the spring to stretch 15 centimeters. So those are that pair of values that we can work with. Okay, so that's what I was saying about that pair that we would use in step 2. So to write a variation equation relating S and M, firstly, those are our two letters, so we can write S equals to Km. So what we know here is we need to work out K, and we're using those values that I've highlighted in blue. So we know that a load of 24 kilograms, so load is the mass, causes the spring to stretch 15 centimeters. So that's a stretch. So that's the S value. So we're going to put in when S equals to 15, we know M is equal to 24. So this is where it's really important that you have the letters the right way around, or you know which one's which. Okay, make sure you don't mix them up because then you'll end up with very different answers. So when we substitute those in, we've got 15 equals to K times 24. In order to make K by itself, we're going to move the 24 over and divide by 24. So K is equal to 15 over 24, We can simplify that. I might just simplify it as a fraction. 3 goes into both of them, so it's 5/8. So what we know is, from that original equation, that k value is 5/8. So that means our final formula is S equals to 5/8m. And that's the equation. Once we've got the equation, we can then use it to solve problems. So question B, what is the stretch caused by a load of 13 kilograms? So if I'm looking at 13 kilograms, that's a mass value. Okay, so that's M. So we're looking for what is the stretch. Okay, that's what we're looking for. So starting with this formula, S equals to 5/8m, when M is equal to 13, we're going to then work out S. So S is going to be 5/8 times 13. I can put that into a calculator, and it's 8.125 not kilograms. If we're looking at stretch, we measured stretch in centimeters, it'll be that many centimeters. So make sure you follow the right units, okay, according to what you're working with. The last part, what is the mass of the load? So we're looking for what is the mass, M is what we're looking for, that will cause a stretch of 25 centimeters. So 25 centimeters is the S value. So what we've got is S equals to 5/8m. So when S is equal to 25, we want to find what M is. So I'll put 25 here equals to 5/8m. Now we've got 5/8 times m. So what we want to do is get rid of it. So what we can do is divide by 5/8. You could do them separately. So you could times the 8 over and then divide by 5 if you want to. Or you could just divide that whole fraction over. Okay, that should work as well. And then so when you divide by 5/8, you end up with 40 equals to m. So that means the mass is 40 kilograms. Okay, so two things we're doing here. We're looking at graphing relationships which are directly linear, and we're also looking at solving problems. So with the solving problems, sometimes I'll give you all the steps. Sometimes I'll just ask you the one question and then you need to go through the steps yourself. So if we could have a go at those questions, and we're almost done with this topic.